In the final days of October 2025, a small icy body will reach its closest point to the Sun. A small icy body will reach its closest point to the Sun just inside the orbit of Mars at a distance of about 210 million kilometers. Astronomers call it 3I/Atlas, the third confirmed visitor from beyond our solar system. It came from the dark between stars, drifting for millions of years before it crossed the invisible frontier of our celestial neighborhood. Now it's about to face the full fury of our star, and the encounter could change it forever. But what exactly happens when something not born under our sun meets its heat head-on? And why do some scientists whisper that this object might not be a comet at all? According to NASA's planetary defense reports, 3I/Atlas was first detected by the Atlas telescope in Chile on July 1, 2025. Early images revealed a faint tail, already active far from the Sun, a rare sign for any comet. Its orbit isn't a loop like those of ordinary comets. It's a hyperbola, a curve that never closes, proof that it comes from another star system entirely. Astronomers traced its path backward and found no parent star within range. It emerged from interstellar darkness, and soon it will return there. At perihelion on October 29th, the Sun's heat will rise exponentially. The comet's icy surface will begin to boil. Jets of gas and dust will erupt like geysers, expanding into a glowing cocoon, the coma, and stretching into a tail tens of thousands of kilometers long. But scientists watching 3I/Atlas know this one behaves differently. It began venting material long before sunlight could have reached its frozen heart. That anomaly, that premature awakening, may be the key to understanding what it truly is. Ground-based telescopes in Hawaii, Chile, and Arizona report something extraordinary. 3I/Atlas is producing jets of carbon dioxide even in the cold vacuum of deep space. Normally, comets stay dormant until they're much closer to the Sun. This one seems almost self-powered. Hubble's imaging shows a teardrop-shaped coma, flickering with jets that defy prediction. Spectral readings suggest unusual ratios of CO2 to water ice, a mix unseen in typical solar system comets. And its ion tail stretches more than 56,000 kilometers, glowing in ultraviolet light, rippling with charged particles. That tail is so long that two spacecraft, ESA's Hera and NASA's Europa Clipper, may actually fly through it between October 25th and November 6th. For the first time in history, human-made machines could pass through the remains of an interstellar visitor, sampling the dust of another star system. But as the data builds, so does the mystery. Every interstellar object is a messenger. Its composition, its motion, even the way it disintegrates, carries data about the world that created it. If 3I/Atlas formed around another star, it could contain molecules older than the solar system, fragments of ancient chemistry that predate Earth itself. To planetary scientists, that's priceless. Each particle it sheds near the Sun could reveal how other star systems forge comets, how life-giving elements might travel from one world to another. In other words, when 3I/Atlas burns, it doesn't just dissolve, it speaks. But beyond the excitement lies an unease, because this is the third time in less than a decade that an interstellar traveler has entered our skies. Oumuamua in 2017, Borisov in 2019, now Atlas. 3 arrivals, each stranger than the last. Not everyone believes 3I/Atlas is natural. Harvard astrophysicist Avi Loeb, known for challenging orthodoxy, suggests a radical idea. What if some interstellar objects are technological relics? He proposes that 3I/Atlas could be an ancient probe or mothership, using the Sun's gravity to change its trajectory, an Oberth maneuver, the same principle spacecraft use to gain speed by diving close to a planet. Loeb argues that when 3I/Atlas disappears behind the Sun, invisible to telescopes, that's when it could perform its hidden maneuver. Most astronomers reject this notion outright. To them, every sign points to a volatile ball of rock and ice, not alien hardware. But the resemblance between Oumuamua's strange acceleration and 3I/Atlas's early activity keeps the speculation alive. Could 2 natural comets in a row behave like that? Or is there something we're missing? Inside NASA's control rooms and observatories around the world, scientists wait. At the European Space Agency, the JUICE spacecraft will observe 3I/Atlas from the far side of the Sun in November. Its instruments will gather faint reflections, though the data may not return to Earth until February. At Gemini Observatory, researchers fine-tune exposure schedules, hoping to capture 3I/Atlas's re-emergence when it swings back into view. They know these weeks are unrepeatable, a cosmic one-time-only event. For them, it's not about mystery or conspiracy. It's about evidence. The data must speak louder than speculation. And yet, when a glowing object from another star system falls toward the Sun, even the most rational minds feel a tremor of awe. Because watching something born under another sun is like staring at a cosmic mirror. From October 27th to November 10th, 3I/Atlas will vanish in the Sun's glare. To Earth-based telescopes, it will be gone as if swallowed by the light. Somewhere within that brilliance, its surface will reach hundreds of degrees Celsius. Ices will explode into vapor. The nucleus could crack apart, or if denser than expected, survive, polished and darkened. But Loeb and others speculate something more deliberate, that the hidden window behind the Sun could serve as a cover. If 3I/Atlas were under intelligent control, this would be the perfect moment to alter course undetected. Could it redirect toward the inner planets? Could it eject small autonomous probes riding solar wind toward Mars or Earth? These ideas remain unproven, but they echo an unsettling truth. Every interstellar visitor so far has behaved differently from the last. Maybe nature itself is the mystery dot, or maybe the galaxy is full of technologies we can't yet recognize. Astronomers remember 2017. Oumuamua, a thin, tumbling shard, accelerated as it left the solar system, without any visible jets. 2 years later, Borisov appeared a true comet, active but faster and redder than any we'd seen. Now 3I/Atlas combines traits of both, 3 objects, 3 anomalies, each carrying traces of worlds we'll never visit. Some researchers suggest interstellar debris like this could seed planetary formation across galaxies, scattering water, carbon, and organic compounds wherever gravity permits. If that's true, comets like 3I/Atlas aren't intruders, they're couriers. Every system sends fragments of itself into the void, and sometimes those fragments find us. By November, when 3I/Atlas re-emerges from behind the Sun, it will not look the same. Its coma will expand, its nucleus may shrink, fractured by heat. Its orbit will have shifted, slightly altered by the solar wind and gravity it just survived. To the telescopes waiting on Earth, it will blaze brighter, its tail stretched like a ghostly banner. And as scientists download fresh images, one question will linger. What if these visitors are not accidents of physics, but participants in a galactic process we barely comprehend? Every time one appears, humanity turns its gaze outward, questioning its place, its origins, its fragility. Because when something from beyond the stars crosses our sky, we are reminded that our solar system is not isolated. It's just one port in a sea of countless journeys. 3I/Atlas will soon fade again out of sight, out of orbit, back into the dark between suns. But the data it leaves behind will travel with us, reshaping our science, our myths, and our sense of belonging.